Hey everyone, Geophysicist Stefan Burns here with breaking news. A Comet C220P McNaught has dramatically expanded in size and brightness after its second outburst now in the span of about 2 months. So this really started up on August 5th, but it's reached a peak apparent magnitude of 6.5 today, August 7th, and its prior outburst was back on June 3rd. Now this is a short period Jupiter family comet, so its orbit is about 5.5 years in length, and its perihelion was in June. It was the 14th of June, going to about 1.6 astronomical units away from the sun, so just outside the orbit of Mars. And while there's some really interesting energetic connections that can be drawn with these outbursts of McNaught to what's happening right now in our solar system, because not only was this comet along the ecliptic plane and near its perihelion from the first outburst to now the second one in August, it was also embedded within the solar wind Parker spiral that connects the sun to Jupiter. Now it's 1.5 times the size of Jupiter with its coma. The nucleus, of course, has remained the same size. There's this big ejection of gas and dust from deep within the nucleus. Clearly, it getting close to the sun heated up quite dramatically. Its perihelion, again, 1.6 astronomical units. Its aphelion is a little bit further than that at 4.67 astronomical units. So it's at its closest to the sun. It's receiving about 550 watts per square meter of total solar radiance. When it's at its furthest away, it's about 60 watts per square meter. So about a 10x increase in total solar radiance. But this first outburst actually came before that perihelion, and the second one now is afterwards, both of them occurring just a week after a gigantic explosion on the sun triggered a solar proton radiation storm that we measured here at Earth. And so we have this extreme amount of relativistic flux going out. These are protons and electrons and other heavier ions that are being accelerated to speeds near the speed of light, having a tremendous amount of energy. 1 week after those events, the most notable of the past few months, both S1 radiation storms, we get this comet to have an outburst. And because it's embedded within the solar wind Parker spiral that connects the sun to Jupiter, and Jupiter having the biggest magnetic field in the solar system outside of the sun, there's already a natural flow of this relativistic energy down the magnetic field lines to Jupiter. It intersected Comet C220P McNaught, and that is very likely to have awakened it, caused this outburst of gas and dust, which then expanded dramatically in size into this complex dusty plasma coma, 1.5 times the size of Jupiter. And today, right now, it's at its brightest at an apparent magnitude of about 6.5. At its dimmest, its apparent magnitude is around 17.9. So if you go from its absolute dimmest to where it is right now, that is a 36,000 times increase in brightness. So this is a big celestial event that's occurring right now in our cosmic backyard, and let's get right into it. Here we see this comet in exquisite detail with the photo taken by Gherald, Rhemann, and Jager today, August 7th. And we see here its dust tail stretching out, and we see its coma, a bright green color due to diatomic carbons, that's C2, but there's other carbon that's here as well, CO, CN, but C2 is definitely enhanced from some of the spectroscopic measurements that have been taken. And this is about 4.25 arc minutes across. So that equates to, again, about 235,000 kilometers across. The diameter of Jupiter, the largest planet in the solar system by far, is 143,000 kilometers across. The diameter of the sun, for reference, is 1.4 million kilometers across. And the distance from the Earth to the moon at its closest is about 356,000 kilometers across. So this is a big, big object now in the solar system. Of course, so the nucleus itself is very tiny. Maybe it's a kilometer across, 2 kilometers across, probably not even that big. But this coma is quite large. Now, traditionally, a lot of people talk about the coma just as being composed of gas and dust. But the thing is, the moment you have gas and dust in space, some of it becomes plasma. It gets ionized because you have sunlight going out, and this is not just non-ionizing light, but this is also ionizing light. So ultraviolet, extreme ultraviolet, X-ray. And so inevitably, some of that gas ionizes and you get a weak plasma. Also, the dust grains that are in space, they also take on a charge, and that can be about 1 to 10 volts. Well, what happens is the moment you have a weakly ionized plasma, the electromagnetic force greatly takes over, and it can now interact with the solar wind and other streams of energy in much more direct ways. So just the fact that this comet has perihelion on the 14th of June, and it went from a total solar radiance of, at its furthest from the sun, about 62 watts per square meter, all the way up to like 550 or so, really greatly increased the energy available to this comet. Then it has this outburst 1 week after an explosion on the sun triggered this proton radiation storm. And also on June 3rd is when we had a sequence of X-class flares and near X-class flares. So that perfectly corresponded as well. That helped it to grow its initial coma, get big, get energized, get ionized. And now that there is a weakly ionized coma, it can start to interact with the solar wind in unique ways. So the thing is, now we're going a little bit beyond, we're going into speculation territory here, but we do have good evidence for this. Here we see our Parker spirals. And so we see the sun right there, there's the Earth. We see that at this moment in time, the Parker spiral that connects the sun to Jupiter is flowing out like this, effectively in between Earth and Mars. Okay, now this is for the beginning of August, all right? But again, you see that Parker spiral goes out like this. And in general, for the Parker spiral for Jupiter, if you have it connected here, it's also going to be outside the orbit of Mars on the opposite side. See that? Here's the orbit of Mars. See that circle right there? That's the orbit of Mars. So if you want to get exactly in opposition to Jupiter for that Parker spiral, you go outside the orbit of Mars. Now, why am I showing you that? Well, here we have our orbit for this comet, and this is set for today. And so we can line this up, and we will notice that here is Jupiter. Okay, and I can maybe even get that a little better right here. Here is Jupiter. There's the sun. So again, this is going out like this. Here's the orbit of Mars, roughly in opposition, and then it's going to flow out like that. So the Parker spiral of the solar wind is going to go in like this and then connect into the sun. If we go back to June, and this is the 3rd of June right here, right? We see that Jupiter hasn't moved really all that much. So again, that Parker spiral is going to go out and like this, and then just outside the orbit of Mars or so, in that opposition zone. So right about here, actually, it's then going to spiral out to Jupiter. Well, look at where this comet, just in the past few months, has traveled through. It's traveled exactly through that Parker spiral. Let me show you the Parker spiral here again. It's traveled exactly like this because it's gone in and now it's going out, okay? So this is quite significant, and by being embedded within that natural flow of energy going from the sun to Jupiter, it's already going to be getting ionized more and just receiving more energy due to these strong electric currents that are flowing between the sun and Jupiter. Okay, you also have it having increase in its total solar irradiance by about 10, going from again 60 to about 550 or so. And then you have these solar proton radiation storms. Let me show you that really quick. Here we have our space weather timeline viewer. And so we see this most recent radiation storm that occurred right here near the end of July 30th. An S1 storm, pretty big bump also in our greater than 50 and greater than 100 mega electron volt protons, which are very energetic, okay? So these are extremely high energy protons traveling near the speed of light. The faster they are, the more energy that they have. And because they are particles, not photons, photons being the quanta of light, because they're particles and they have charge to them, they follow magnetic field lines. And so you're going to get with a big explosion, this is from a 1.9 M class flare. From a big explosion, you're going to get some of these particles to spread out just in general. Some of them will cut across magnetic fields to some degree, but most of them are going to follow magnetic field lines. And you have, of course, the largest magnetic field in the solar system outside of the sun with Jupiter, creating a natural Parker spiral conduit to it at all times, no matter where it is. And then you get this explosion here. Well, again, that's on the 30th of July. Here's August 5th. This is when we had the most recent outburst, where it's increased 1000x in brightness, going from a magnitude of about 14 to 6.5. Now, it's, apparent magnitude before it had its outburst in June was 17.9, and it's a 2.54 increase every time you go up in apparent magnitude. So it scales like that. So the original outburst was about a 7,000 times increase in brightness, because it went from 17.9 to about 8.3 in apparent magnitude. But this most recent one is about a 1000x increase. But if you look at its overall state, going from its lowest at 17.9 to now at 6.5, again, it's about a 35,000 times increase in brightness, which is huge. And also the coma is expanded dramatically more. Well, let's go back here and we see this other radiation storm, right? Here it is. That's the last radiation storm that we had before the one that occurred at the end of July. And that was right there at the 26th, basically starting up right at 0 midnight universal time. And well, June 3rd is when we had the next outburst. Look at the solar flares that occurred right at that time. So if you take the time in between the 26th of May and June 3rd, you get 8 days. And then if you go from the 30th of July to today, you get 8 days. Though this outburst started back around August 5th, it's peaking today, it seems. So that's about 6 days. So you get effectively 1 week between these solar proton radiation storms and these outbursts of this comet right around its perihelion period in its 5.5-year orbit back to back. And specifically for this outburst, that solar proton radiation flux, because it's relativistic, some of it is going to pierce deep into that nucleus and can cause likely deep heating, paired again with that dramatic increase in total solar radiance that it has because it's near its perihelion. That can then cause there to be this superheated ejection of gas and dust. And again, the moment it enters into the space environment, it weakly ionizes because of solar radiation. And guess what happens the moment this outburst occurred on the 3rd? We had this sequence of solar flares with this 1.0 X-class flare, a 9.3 M-class flare. So it was like it had this outburst, created this huge coma, and the moment it did, it was able to grab some of this energy from the sun as a result of this flaring. I find that very, very interesting. Again, that occurred just before its perihelion on the 14th of June, and now it's had a new reactivation, again, perfectly timed with this solar radiation storm. And this time it's getting even brighter because it just had a higher threshold to work from. It wasn't going from a deep slumber like last time. Here we see our light curve for this comet. So our measurements back there we see, and this is the 18th of May or so, and it's 17.6 for the instrumental value for apparent magnitude, 17.9 for May 28th. And then look at how it just jumped up dramatically here, going to 8.2, 8.3 is its highest value there. It then decreased to, again, about 14. So it did reach that magnitude that you'd expect for its perihelion. You have these simple fits. I can show you that really quick. If we reset our axis, we see that it hasn't had these outbursts before, just at least for its most recent orbital periods there. And here is what happened in August. Just a huge increase, well beyond what is expected. And now it's again getting close to an apparent magnitude of 6, which is right at that limit of what you can see with the naked eye under perfect dark sky conditions. So this is like a huge beacon lighting up now pretty close to the orbit of Mars, so not that far away from the Earth, in fact. This is the NASA JPL orbit viewer, and this is set for today, as you can see, the 7th. And we notice that it's just slightly inclined off of the ecliptic plane. So its inclination is 8.12 degrees. So it doesn't have a huge inclination off the ecliptic plane, but there is a little bit. We notice that during its perihelion, it cut through that ecliptic plane. That's when it has the ability to be embedded within the solar wind, because you have the solar wind flow out and it forms these ripples, these undulations. Think like a ballerina skirt. but they don't extend super, super high above the ecliptic plane or the solar equatorial plane, okay? They kind of ripple out like ripples on a pond. So when something is cutting through that ecliptic plane, that is when we can expect it to get coupled and connected to the sun and other planets, perhaps, if it's within those Parker spirals. So that's exactly what happened here. It cut through and got connected to Jupiter just based off of its location in the solar system. And also because these solar flares that hit were Earth directed, we had solar storm impacts from that, it was also in this location that it would receive that particle flux from these explosions, those proton storms. So it really seems quite perfect that this comet had these outbursts perfectly timed 1 week after these solar proton radiation storms, perhaps triggered by its connection to Jupiter, that being almost like an enabling agent for that to occur. Because we've seen other comet outbursts in the past. Comet Holmes, for example, here is the most notable, 17P Holmes. It had a big outburst on the 23rd of October in 2007. I was not able to find any proton radiation storms that lined up with this, any significant solar flare activity that lined up with this. So it did it of some other mechanism, and that's certainly possible. But the thing to point out with this is that its coma grew so large that it was actually about the same diameter as the sun. And that's what we saw with 3I Atlas. It had this huge coma at one point near its perihelion when it was on the other side of the sun from Earth. It really expanded out. There's tons of solar flare activity that started up and was launching out towards 3I Atlas. And it then had this close flyby of Jupiter. These comets form these magnetic fields. Don't forget that. They have magnetic fields to them. So it's not that they are just flying through, and again, it's just gas and dust as they travel through space. And we've measured this with Halley's Comet and the Rosetta mission. They have these cometopauses that can be 30, 50, 300 nanotesla in strength. Normal solar wind magnetic field is 5 nanotesla. So that comet flying by Jupiter, again, the biggest, strongest magnetic field in the solar system outside of the sun, is going to create a magnetic tether. So 3I Atlas then formed this energetic connection to Jupiter. It's now flying out. It's probably going to stay connected to Jupiter somehow energetically until 3I Atlas reaches the edge of the heliosphere. But in general, for the next 5-10 years, I think there's probably going to be a remnant energetic channel that exists between the two. And we see McNaught now having these outbursts as it's embedded within this energized channel flowing from the sun to Jupiter. So the thing is, as these outbursts occur, you get that coma expansion, you get the dust to form these electrostatic charges. Again, it can be like 1 to 10 volts under normal conditions, but under heavy load, it can be up to kilovolts. And they can have long range interactions with other dust grains, which have charge to them, and they can form these plasma crystals. And the moment you start to get these crystalline dynamics, that's when effectively it can be like a transistor, a gate, a 1, a 0. There can be computation effectively. So this is very, very unique. We don't see these often. This is one of the biggest cometary outbursts that has been observed and recorded, and it's occurring right now. And another interesting thing to point out with this comet is its orbital period at 5.5 years, meaning it does one revolution, one orbit around the sun every 5.5 years. And again, we can look at our orbit for this, and we see that it goes from just outside of the orbit of Mars to Jupiter, meaning it is flying through the asteroid belt with every 5.5 year orbit. But I was thinking, okay, well, what's the resonance here? Because what we see with the planets is that they often form these resonances, or the asteroids, they have resonances with the planets. And so this is a near 1 to 2 Jupiter resonance, because Jupiter's orbit, its period is about 11.8 years or so. You can round it up to 12. But 5.5 and 12 are close, but they're not exactly half. Well, the average solar cycle length is 11 years. So this comet here doesn't specifically seem to have an orbital resonance with any of the planets, so it's kind of close to Jupiter again, but it does have a perfect resonance with the solar cycle, which suggests that it does have a connection to the sun that's quite intimate energetically because its orbital period is tied to that solar cycle. At least they are converged upon similar frequencies. So the fact that we did see these two S1 proton radiation storms seemingly trigger these outbursts both 1 week after they occurred, and specifically for the June 3rd one, coinciding also with that period of heightened solar flare activity with the M-class and the X-class flares. That's very interesting, and all that was occurring while it was embedded within the Parker spiral, flowing from the sun to Jupiter, perhaps allowing for this initial triggering to occur because those solar protons flow down that established magnetic field versus this just being somewhere randomly in space and only getting lightly hit by that radiation flux because it's cutting against the magnetic field and it's just not flowing down the trough, let's say. Like there's canal systems, water, right? Where's the water going to flow? Well, it's going to flow in the established channels more so than just trickling down the hillside. So it's similar to that. So this is very interesting. I don't exactly know what this means beyond this, but energetically seeing this activation of this comet both before and after this historic planetary geometry that we had in July, it's still active, by the way. This is, of course, the larger configuration that we're seeing between Jupiter, Uranus, Neptune, and Pluto, Saturn being in the middle of this basket. The fact that this outburst occurred on both sides of that is really interesting. And also it's peaking today, August 7th, 1 day before the 8/8 Lionsgate portal and just a few days before the August 12th total solar eclipse. So I'll be back with more information, but we're having this big cosmic messenger basically wake up even to visible eye conditions in super dark skies, definitely binocular conditions. A lot of people are making sightings of 220P McNaught with their binoculars, and we'll continue to see what it does. It has the potential to brighten even more from this point out, especially if you get some solar activity, though at this point, the Earth-facing side of the sun is almost devoid of sunspots. So these may be the only two outbursts that occur, though perhaps a little bit later, like a few months from now, we get another one. There is one last thing to note, which is, well, what about the big radiation storm that we had at the beginning of the year? Because you notice we had this crazy radiation storm, one of the strongest ever on record here back in the middle of January. And there was the significant planetary alignment that was active at that time. Okay, so we can go back here to our viewer and we'll go back to around that time of the radiation storm. It was around the 19th or so, a few days on either side. Okay. So why didn't perhaps that solar radiation storm really bump it up? Well, it's not really within that Parker spiral magnetic field connection at that point. And also, you'll notice it's more highly inclined. So the solar wind, again, flows out mostly along the ecliptic plane. So it's kind of in the location for the Parker spiral connection. It's starting to enter into it around this time frame, but it's inclined above the ecliptic plane. It may have never had a connection in the first place, but now that it has flown through that ecliptic plane and into the solar wind and the heliospheric current sheet, now it can get that connection. So that's probably why that occurred. At least that's my thought process there. But I'll keep you up to date. Thank you so much for watching the video. Please smash that thumbs up button to help the channel grow. Subscribe to stay updated on everything that's occurring with the Earth energetically, with our star, and with the cosmos. I release video updates almost daily. I've been your host, Stefan Burns, wishing you all well. Have a great day, and I'll see you all in the next video.